Okay, so we're going to have a look now at section 7.4, I think it is. Yes, 7.4 vectors in 3D. And we're just going to have a little look and maybe try and have a go at example 14 and just show you basically what's happening. Okay, so say for example, you in 2D you've just got the x and y axes, otherwise known as I and j in component form in vectors. In 3D, obviously, you've got the x, y, z axis. So basically, if we imagine that we've got, this is the x axis, or sorry, that's the y axis. I'm going to let that be y, and this x. Okay, so we'll say that's x, that's y, otherwise I and j. And the z-axis is like, so imagine that's on a floor, if you like, that's flat. And the z-axis is going to come up into space, okay? So that would be the z-axis. So I, j, and k in component form. Now, say, for example, that you've got, say this is the origin here. I'll put that here. So this is the origin, which otherwise is known as the point 0, 0, 0. Now say that you've got a point coming out into 3D space. So it's moved, so x and y are flat on the floor, but this point here is coming out into 3D space. Okay, so we're going to call that one point A. And it's going to have the coordinates 1, 5, minus 2. Now, obviously, it doesn't look like that, but I'm just going to use that because it's example 14 in the book. B, so we say we've got B, which is 0, 0, minus 3, 7. So we'll put B out here. Okay, so B is 0, minus 3, 7. Okay, now these are points in 3D space. Now they're points at the moment. They've got 3 components to them. They're points. If we were to refer to them as position vectors, a position vector is a vector relative to some fixed point. In your work that you're going to be doing, that fixed point is going to be the origin, 0, 0, 0. So the position vector, OB, that is now going to be, well, 0i minus 3j plus 7k. And OA is going to be I plus 5j minus 2k. So these are now position vectors, if you like, and we can obviously write those in 3D, 0, minus 3, 7, as column vectors, 1, 5, minus 2. So also the unit vectors, now the unit vectors, we can still have those. Now remember, they're just one unit out. So in this particular case, the unit vector would be 1, 0, 0. If we're moving alongside the y-axis, the unit vector would be 0, 1, 0, and the z-axis is just going to be 0, 0, 1. So those are now our unit vectors. So basically what we can do now is and in example 14, I think you have to work out, let's just have a look. We're finding the position vectors of A and B in IJK notation. Well, we've done that already. And AB, we're moving from A to B, so we've got to find the vector as a column vector from A to B, right? So we're going from A, which is 1, 5, minus 2, to B, which is 0, minus 3, 7. Now, clearly, if you're going from 1 to 0, you're taking 1 away. If you're going from 5 to minus 3, you're taking 8 away. And if you're going from minus 2 to 7, you're adding 9 on. That's it as a column vector. So this is equal to AB, vector AB. Obviously, if it was in our JK notation, it would be minus I minus 8j plus 9k is equal to AB. Similarly, if we wanted to work out the magnitude of, say, vector AB, we'd just say that it's the square root of 1 squared plus 5 squared plus minus 2 squared. So that would be the square root of 2630. So the magnitude of AB, always the straight symbols there, as 25, 26, yes, 30. Okay, so the magnitude is exactly the same as in 2D, except you've got this third value here that you're going to work out. Okay, so that's basically IJK notation, vectors in 3D, how to work out the magnitude of a vector in 3D. Oh, so let's go and have a look at the example in the book. I'm just going to get rid of that. Okay, so have we worked out, find the vector AB as a column vector? Well, they've done OB minus OA, so OB is obviously 0, minus 3, 7, because you haven't got an I value. Minus 1, 5, minus 2 is minus 1, minus 8, and 9. So that's basically another way of working it out. Okay?